In this video, we're going to continue looking at the inverse trig functions that we discussed previously, specifically cosine and sine, and how to solve for an exact angle when we know the values here that sine theta or cosine theta are equal to, so if we know this ratio. When we're working with robot kinematics, we're going to come across equations of this form. So we'll have two equations. The first one is a cosine theta minus b sine theta is equal to e. And here a, b, and e are all constants, so these are numbers that we know. And we're trying to find the value theta. And then we also have another equation, b cosine theta plus a sine theta is equal to f. So in this situation, we will use the techniques here to find out what the angle theta is. We can rearrange to get cosine theta is equal to this ratio, and again, since we know all these numbers, this is just a number and it's either going to be positive or negative. And we can rearrange to get sine theta is equal to this number here. So we've got different scenarios. Each of these ratios could either be positive or negative, and so there are four different cases, both negative, both positive, this one negative, this one positive, this one positive, this one negative. So for those four cases are going to correspond to the actual angle theta being in one of the four quadrants in the xy plane. So for example, say this number here is positive and this number here is negative. Well, for cosine theta of a positive number, the inverse cosine is going to give you a value in the first quadrant. So that means that the actual angle is either in the fourth or the first quadrant. And I said that this number here is negative, so for that being negative, sine theta is going to give you a value in the fourth quadrant. So that means the actual angle is either in the first or the fourth quadrant. So we want to find out now which case that is. Okay, so cosine theta is a positive number. The calculator is going to tell you that theta is in the first quadrant, whether or not it's in the first or the fourth. See, the red line is what the calculator tells you. So it tells you it's in the first quadrant. Sine theta is a negative number. Well, then inverse sine, the calculator is going to tell you that the angle is in the fourth quadrant. And so for the situation where the calculator tells you inverse cosine tells you that the angle is in the first quadrant and inverse sine tells you it's in the fourth quadrant, then you know that's the case where the angle is actually in the fourth quadrant. And so the value given by the inverse sine function is the actual value for theta. Another situation, say they're both negative. Say this is negative and this is negative. Well, in that case, inverse cosine is going to give you a value in the third quadrant. I'm sorry, in the second quadrant, this red line here. So this red line is for a negative value. And inverse sine is going to give you a value in the fourth quadrant, so one of these two. So the actual angle that would give you inverse cosine in the second and inverse sine in the fourth is an actual angle in the third quadrant. So that's this row here. And so for that case, you would use pi minus the inverse sine of the value. And that's how you would get the actual angle theta. We will look at some kinematics problems and use these equations, and hopefully by example, the concept will become more clear.